But yeah, thanks everyone for joining. Yeah, so the platform team at SDF did a small hackathon last week, and we really wanted to just create projects and showcase how fast, easy, and cheap using our composable data platform really is. We have a wide spread of different projects from like tiny applications to full-blown applications to like some more back-end like components to help out with things. To start off, I believe Tamer, if you're ready, is going to present about his trade ags hacky.
Yeah, thank you, Simon. I'm gonna go ahead and share my screen. Okay, so as Simon mentioned, I worked on a trade aggregations service for my hackathon project. And the motivation for why I worked on that is because we have a trade aggregations endpoint in Horizon, and it is one of the most problematic endpoints for Horizon in that it consumes a ton of the database resources to the degree that we have special rate limits just for trade aggregations that are more restrictive than other endpoints. And also it has one of the most complex implementations compared to the other endpoints with really complicated SQL queries in Horizon. So it's been a perennial problem for us in terms of scalability for a number of years now. And I wanted to see if we could do something better than what we have in Horizon if we just started from scratch. And the answer to that is resounding yes. The new trade aggregations prototype that I built had an average response time which was 10 times faster than Horizon. The size of the database was also 10 times smaller, and it could handle 5 times the traffic of Horizon's for Horizon's trade aggregations endpoint, and the cost was less than $500 a month. So before I get into the details, I'll just give a bit of background of what trade aggregations are. So on the Stellar network, you can perform a trade either through consuming offers on the DEX, or you can trade through liquidity pools. And a trade basically consists of exchanging 2 different assets. So one asset you can think of as being sold, the other one is being bought. And there's an amount that is sold in exchange for the amount that is bought, and the ratio is the price. And there is a timestamp associated with that trade, which is inferred from the ledger close time. So a trade is an operation that occurs within a specific ledger. And a trade aggregation is basically a way to compress all of this trade data. So you can view all the trades that have occurred on the network, and there will be a number of trades occurring in each ledger. But you can sort of compress them by summarizing what happened in different intervals, which we'll call resolutions. So you could provide a summary over 1 minute buckets, 5 minute buckets, 15-minute buckets, and then the trade aggregations endpoint supports up to 1 week buckets. And that summary for a trading pair in a particular bucket will be the number of trades that occurred. So like the number of trades between USDC and XLM that occurred in a 5-minute period, the average price during that period, the highest price and the lowest price, the total amount that was bought and sold, and then the very first, the price of the very first trade and the price of the very last trade in that bucket. So I have a demo that I've recorded, and here I'm running the new trade aggregation service, and I just did a request which sampled a resolution of 1 minute, and it looked at a 5-minute period, and it got back a response from the new service in about 57 milliseconds. And now for comparison, I'm going to request the same data from Horizon, and the Horizon response took a bit longer, 660 milliseconds. But you can look at the data in the response, and you'll see that it's identical. And then I'm going to try another request now that will actually query, that will aggregate in buckets of 1 week, and it'll query a year's worth of data. So this is going to be more resource intensive because the previous one just queried 5 minutes. This one's going to do a year. That is done. This request just occurred on the new service, and it completed in 1.5 seconds. So now I'm going to do it against Horizon, and you'll notice that it will take a bit longer. So it's running, and it's taking 1, 2, 3, 4, 5, 6, 7, 8, almost 9 seconds. So 8.69 seconds compared to 1.5 for that large request. So let me, okay, yeah. So the Horizon implementation for trade aggregations, it stores all the trade aggregations in one table called History Trade 60,000, and it has each row in that table has 1 minute aggregations, and then to derive the aggregations for longer periods, it will do it on the fly in SQL using like a group by. And so that table actually occupies 79 gigabytes of space, 51 for the table, and 28 for some indices. And in comparison, the new service that I prototyped, it used Bigtable instead of Postgres, and the database size was only 7.5 gigs compared to 79, and I was able to ingest 1 year of data in just 7 hours and 21 milliseconds. 7 hours and 21 minutes. And the peak memory consumption was just 1 gigabyte when I had to do that huge backfill, and it used like 2 to 3 cores during that backfill. But once we were caught up, it was able to ingest the latest ledgers very easily with minimal resources, only 100 megabytes of memory and like less than one CPU core. And the cost, I only required one node, one Bigtable node. Bigtable can scale out to lots of additional nodes, but one is more than enough. And the cost of that is just $485 for 100 gigabytes of storage. I only needed 7.5 for 1 year. And then in terms of like load testing, I did a load test at 20 requests per second, which is the amount of trade aggregations requests that the public Horizon instance that SDF maintains serves. So 20 requests per second is like what we handle in production in Horizon. And I did the load test both on Horizon and the new service. The average duration was like 420 milliseconds for Horizon compared to 29 milliseconds for the prototype. And there were in Horizon there were 4 timeouts in that sample of 10,000 requests, and a timeout is like when it goes beyond 10 seconds. Compared to the prototype, where the longest running request was just for 1.4 seconds. So then I doubled the request per second up to 40, and Horizon increased slightly in terms of the average, went up to 430 milliseconds. The prototype also increased and went up to 41 milliseconds. And then, but still, there were no timeouts on the prototype, whereas there were 5 timeouts in Horizon. And in the next load test, I tried to go up to 100 RPS. But what I observed was that the Postgres database was completely maxed out. So this graph is from AWS, and you can see like the green represents the CPU usage, and this dotted line represents like a maximum. And so we were like fully utilizing the database at this point, and it could not go beyond that. Whereas with the prototype, it was able to handle it without any problems. The average duration went up to 83 milliseconds, but again, no timeouts, and the max longest running request was still around like 1.4 seconds. And unlike Horizon, which used up the entire CPU utilization for Postgres, with the prototype, it was less than 25% utilization of the big table CPU. So the recommended utilization for big table is like less than 60%. So we have enough capacity to go double and to try to even handle 200 requests per second. So in summary, the prototype consumed 10 times less disk space, was 10 times faster in terms of request duration, and utilized much less DB CPU utilization. And that Horizon Postgres instance is actually very, very beefy, and it costs like over $5,000 per month to run, whereas that one big table node is a tenth of the price at $485 per month. The ingestion time for 1 year was 7 hours and 21 minutes. I think it would be much longer for Horizon.
Yeah, you're at like 10 minutes. You have like 30
Okay.
seconds if you want anything else to wrap up. Yeah, sorry for interrupting.
Oh, no problem. Yeah, no, that's a good point to end on. That's all I had anyways.
Cool, perfect. Yeah, so Sid is now back, and she will now handle being the presentation police.
It's never a dull moment on Discord. I always think I've figured it out, and I'm like, oh, I'm gonna use the desktop app, and then only the web app's working today, so it's amazing. Anyway, apologies for technical difficulties. Tamer, that is so cool. I love that you were able to ingest a year of history in 7 hours. That's amazing. Next up, we're going to hear from a group that studied a fraud case. So Sean, Karthik, and Harsha, take it away.
Cool. Thanks. Hey, yeah, my name's Sean. I work on the Stellar platform team here, and I'm joined by my fellow coworkers, Karthik and Harsha. And together we participated on the hackathon, and we thought it was a really good opportunity to explore ideas for detecting fraudulent or illicit account activity on the network. As this is a really timely aspect for most blockchains. So we created a proof of concept which will ban new transactions that are closed on the ledger in the Stellar network and look for questionable account activity, such as fraud, that are related. And we used the Composable Data Platform, and we used several components of it during the POC development. And as a result, the majority of our development time was spent purely on application features. We were able to focus on that and the related aspects of how our user can monitor fraud and the full stack code that we wanted to develop to accomplish that. And we didn't spend much time on network data ingestion or related infrastructure, all thanks to the Composable Data Platform proposition and what it offers. So with that said, I'd like to turn it over to Karthik, who's going to show you a demo of the proof of concept we built.
Perfect. Can you guys hear me?
Yes.
Very good. So I have here, I'm going to go by this README page on the GitHub repo, where we have mentioned the instructions to start up and build the demo, including the prerequisite Docker images. I have ahead of time started up all the services, so we can just go to the browser and log in. And as a part of this, we have integrated with Google OAuth. This is the name of the client, auth client for Google, which is our application requesting permissions. You log in, and this is our fancy new dashboard where you can register addresses at the cadence. You can register at the cadence of addresses if you want to monitor activity, or if you want to monitor all activity on accounts that are marked fraudulent. So as a part of our demo, I have my Freighter app right here, which I'm going to log into. I'm going to simulate a transaction. These are my accounts. In anticipation of this demo, we have gone ahead and injected or ingested 3 accounts as bad so that we can see traffic and data and network activity come through. So account 4 might be thinking, gee, wouldn't it be nice that if I can find out if account 1 is malicious or not? And so what a person who is interested might do is go here, grab the address, add it, and there you have it. Right now, there is no activity yet. So let's simulate some activity. I'm going to go to account. Let me grab the. I want to stop spinning. Okay. I'm going to go back to account 5, and then I'm going to grab this address, which is my account 1, and I'm going to send some money to it. Let's say test account 1 bad. Review send. There you have it. And this is near instantaneous. So just for the more curious people, we have a Kafka event, Kafka topic on which events will stream through. And once it comes here, well, there you have it. So if I go to my activity, I was like, this person who had registered a watch on this bad account 1 just detected some activity, and for ease of convenience, you can navigate to this URL and it tracks. This is the activity that we were talking about and the transaction that I just made. So if I go back to the dashboard, let's say, let me set a watch on all the bad accounts in the universe of bad accounts that we have. So I can just subscribe to monitor all activity. And sure enough, if I do a transaction from, let's say, let me grab the address of this bad account 3, copy. Let me go to this good account 5 and then send some money to bad account 3. Continue, let's say 55 XLM, and say test all activity. And then, okay, let's see if we have some activity. Of course, once you go to, you can always view all of your activity here. Some refresh might be warranted, as in when the Kafka message comes through on the topic. Oh, I meant to click on back to activity. Sorry, my bad. And this is the new activity that I just registered. So this is just a small preview of what is possible when you can buy. In this particular application, you can easily extend it to send notifications, what have you. You log out, you log back in again. And you can still retain and see your activity. And you can go ahead and add as many addresses as you want. That was it for my part. I'm going to pass it on to Harsha now for the next part of the presentation.
Thanks, Karthik. So you can see that we were able to perform real-time monitoring on all the accounts that we are interested in to do this, right? Like CDP let us do this in a fast and efficient way. Actually, without CDP, we would be spinning up captive cores. We would be, constrained to spin up our own storage service and all that. But with CDP, we were able to directly inject the data in real time and detect all the fraud activity and surface it onto a monitoring scale. I mean, we can improve the scope of this project to perform some machine learning to prevent potential fraud from even happening, right? Like tagging. We can keep a running list of monitored accounts. with CDP, we will be also able to go back in time and get information. Like right now, what you have seen is everything that happened as a forward, move forward thing, because like Karthik was able to inject transactions while we are looking at it. But CDP allows us to go back and get information as an indexer as well. So we could surface all that information, like uh, yeah, all that. The main thing we wanted to still drive home is CDP has a lot of built-in helper functions as well. It reduced the amount of setup time for needed for us to purely concentrate on the application itself, instead of spending time to spin up servers, storage, and all that. Yeah, Sean, do you want to speak a little bit about the helper functions and all the past thread activity checks?
Yeah, sure. Thanks. You covered it at a high level. Yeah, we have helper functions available as a new package in under CDP, and one of them is like called apply ledger metadata, which we show a link to there in our bullets under the README there. And yeah, there's some utility there. So you can really reduce the amount of client code that you need to develop to get network data now with these helper functions, literally down to just like a couple lines of code. You can be live to Stellar network data and nothing more. So it's really a much smaller footprint for the client application to start processing metadata from the Stellar network. And that basically concludes like what we've learned while we were developing against CDP to create this proof of concept. I think that's it for us, unless anybody else had comments.
That's it from us.
All right. Thank you.
Great job, guys. I love that
Thank
you
you.
extended some of our CDP functionality beyond just the batch context in which we've been using for re-ingestion in Hubble and extended it to streaming. Very cool. All right. So next up, we are going to hear from Simon. He's going to show us what is cool about like how the groups decided their projects is some groups decided to go really, really deep. So in like a very simple idea and like build it all the way out to a fully functioning UI. Simon actually had the opposite approach where he went breadth and he wanted to see how many different prototypes he could build in a week. And so I won't give it away. He'll tell you about that.
Yeah, a more chaotic approach. But yeah, welcome to my CDB Hackies presentation. Yeah, so for my Hackies, I really want to showcase more of like a non-sequential ingestion of data with CDP. Basically, where this another way is, I want to show that you can use CDP in a way to get only the data that you want, even if it's like out of order. And then I want to use this to emphasize that CDP is again, fast, easy, and cheap. So yeah, and like Sid kind of foreshadowed or hinted at, yeah, over a week of hacking, I was able to create like a bunch of different applications or like components. I was able to make like a contract data indexer, a payment indexer, a contract expiration alerter, generic data indexes in like DuckDB, and then also like torrents that used to share like these data indexes or ledger metadata files. Yeah, so one of those hackies was the contract data indexer. At a high level, all this really does is get the contract data for contract IDs in a given watch list, where like the flow is really to give a watch list of contract IDs, figure out what specific ledgers you really need to process this in like a non-sequential order, and then you can save and like output this however you want. Here's a small GIF of this in action. I'll let this run a couple times, but yeah, when you execute it, you can see that for a given contract, it'll start like reading from Galaxy or from our data lake of ledger metadata files. Yeah, and then going a little more in depth, this is a simple watch list like JSON file. Essentially, it's a list of contract IDs that you would like to actually watch. So for getting the non-sequential data or like the ledgers where only the specific contract actually had like an invocation or had like notable activity. I created another like small index within DuckDB that's essentially a pair of contract ID and then every single ledger sequence that it could have been acted on. this table is like really fast, easy, and cheap because of like how condensed and like small it is. And then I also want to show that just because we're talking about CDP and stuff doesn't mean you can't use like existing services still, like such as Hubble. To create this index, I actually used Hubble because it already has like the process full history, and it's very easy to write a query to get like the pair of contract ID to every single distinct ledger sequence that it had any activity in. Yeah, and then from there, this was a little more this is a frozen view of the output from the execution from before, where like in the top right green box, you can see that, oh yeah, it's only looking at the specific contract ID that was in your watch list. And then left green box, you can see that, yeah, the ledgers are being accessed, which aren't like purely sequential. You'll see some repeats because in a given ledger, there could be multiple contract data ledger entries. So that's where you'll see like some duplicates. Yeah, and then for the output, like you're free to store it back into like a DuckDB table or like Postgres or whatever your favorite database is, or like that can be used to feed an API. Or you can like throw it into a JSON file. This is however you want to deliver it to your end users. And then one other benefit with using this is you can pick and choose whatever data you want because you're reading ledger metadata files. You can pick and choose what to add or remove when you're serving your users. The next Hackies project I want to talk about was a contract expiration alerter. At a high level, all this does is alert when any contract ID in your watch list expires, even if it was in the past. One other thing I want to showcase with this, or makes this slightly different, is you can use a combination of different ingest patterns. Like as highlighted in green here and bolded, you can also still use real time or like quote unquote close to real time ingestion while also looking non-sequentially at throughout your data lake to get the ledger sequences you actually want to process. Yeah, and then from here is another GIF of execution. I'll let this loop a couple times, but yeah, at the top you see 3 contracts that were alerted because they're in the past, and then you can see the application continuously reading the next ledger sequences. I know this is not current because this was recorded in the past. Yeah, and then a little closer look. Yeah, your watch list for that for my current run. And I gave it basically 5 different random contracts. Some expired, some not. And then at the bottom of the screen, you can see that, yeah, some of these contracts have expired. This is the contract ID. They expired at this ledger sequence. And then another hackies that I did was I also thought it'd be fun to like throw some of this information into torrents, making it easier to share like ledger metadata or like the data indexes I created. Um, and you can see here from like see the index underscore database.duckdb file or the LCM underscore files, which is the ledger metadata files. What was also really cool is if you see highlighted in the green box or within the green box, I guess there's like certain bots that exist within like with torrents where I guess certain trackers or people just kind of like scan through the tracker looking for things, but we actually have a random seeder that I'm not connected to, but like that exists, and a bunch of peers that I'm not connected to, but also exist. It's kind of a cool thing that kind of happened. It's like small automatic decentralization. Yeah. And then, oh yeah, the other thing with torrents is it's also possible to download only the ledger metadata files that you want to use. Um, Again, further making it like faster and easier and cheaper just to use the data that you want. And you can see here in the green box that you can just select a single ledger if you don't need it, or select or the opposite of that, select only the ledgers that you do want to download and use. Yeah, and then from there, I want to go a little more in depth to show how all these hackies really fit within CDP. From here, you have like the CDP as it stands today, where you have Galaxy writing ledger metadata files to a data lake. Then you have an ingest backend that can read this data, and then you process it however you want and send it to like whatever application. So yeah, so for my hackies, a lot of the applications, of course, will fit in the application section. This will work with the current existing CDP, but like mentioned before, it would be actually really nice if you could have non-sequential data access, because then you only get the specific data that you want, making everything even faster, even cheaper, even easier to use. But yeah, then the question is, how did you get these ledger sequences to process? That's where this generic indexer came in again. You can get the with its generic indexers, you can just use the pair of maybe an account or a contract ID to the ledgers that it works on. Maybe you only want like data for a specific contract, or maybe what's another example? Maybe you only want payments where only certain accounts are involved. And then from there, you can further customize things, like from a processor standpoint, because you can process again only the data that you want to process. Maybe that's only payment operations. Maybe that's only TTL information for contracts. Yeah, and then with that, the final thing again was torrenting out or creating torrents for some of these components. This again allows for some semblance of decentralized access to the ledger metadata files or the pre-processed generic data indexers. This lets users or allows users, so like there's no need to create your own full data lake. There's no need for a user to run full history just to create this generic indexer. You have like these torrents that exist that already give you this information. Like not every single person has to run everything all at once. It's a wasted work. So yeah, so all of this together shows just how fast, easy, and cheap CDP is at getting basically only the data you want. And I believe that was it. Yeah, thank you, everybody.
Nicely done. Hey, Karsten, I think for the next group, we need to give Amisha screen share permissions. I can't figure out how to do it. I don't know if you're able to do that. We can't hear you if you're talking. Misha's on the stage. Or the other person, if you could see if Urvi can be given screen share permission. She's also on stage. Her username is Ursa. Oh, maybe Amisha got it. We can't hear you if you're talking, Amisha. Okay, while we figure out those technical difficulties, George, if you're ready, we could tee you up first and then see if we can get permissions correct.
Sure, let's do it.
Let's
All
do
right,
it.
everybody. I am going to be presenting a little quick hack that I like to call browser-based ingestion. So, insights with just a browser. What does that mean? That means a world in which you don't need a Stellar core, you don't need Horizon or Stellar RPC to get any data about the network. You just need your browser. So yeah, this means you can ingest data in real time and historical data and newly minted data without needing a proper backend. So this is the world before CDP in your browser, where your dApp connects to an RPC service and reads historical data and paginates it and filters it. This could be Horizon or Stellar RPC. That runs this big fat core node that's connected to a validator network. Super complicated, super boring. We're gonna make it look like this instead. So now your dApp just connects to a data lake that you create once and use everywhere, and you can read historical data directly from it and not have to have any intermediate services in the way. So an easy recipe that we're going to build is, well, that I already built and we're going to see, is a payment indexer. So step one, all you have to do is authenticate to GCS via OAuth. Then you're going to stream and ingest ledger metadata via the JavaScript SDK, which is new functionality I've added to read information out of transactions and make it nice and easy to work with, which we'll talk a little bit more about later. You can configure payment filters, and you can see in real time payments coming in based on the filters that you've assigned. So super easy, 1, 2, 3, 4. And now we're going to see the demo. So I'm going to switch over to this tab, which is my amazing UI that I've built. These are all little demo. These are for the purposes of the demo so that I don't have to memorize every single one of these long G addresses for my filters. Basically, what we're going to do is start streaming. And here we go. These are the last 10 ledgers that have been closed, and you can already see the payments. These are all being extracted out client side on the JavaScript end. So you get the raw information from each ledger. And here we are seeing all of the payments in XLM that are happening. Say I want to see all of the USDC payments that are happening as well. So we're going to add a filter here, and boom, in real time, even for historical stuff, all the way down at the bottom, we can see the USDC payments that occurred. Say we want to add another filter. Say we want to see all the Aqua payments. Add that in. Nothing really changed because those are less common than USDC. Let's see if we can find one down here. Maybe not. It looks like someone hasn't used Aqua in a while. Oh, there we go. A bunch of little Aquas were sent all over the place. This is probably the issuer. All of that in real time, once again, all browser side. And we can even load historical data. So I'm going to stop streaming here just to show something funny here. This is a ledger in which someone sent to the Galaxy Void, which is the address that SDF burned, a few million lumens on a few years back, and nobody has access to this account. And several months ago in this ledger, which we can load right here, we could see that somebody decided to burn 70 XLM on the Galaxy Void account, which I think is funny. And you can also see the USDC and Aqua payments also filtered in real time right there. So that's the demo. Back to the presentation. So what does this mean? So it means with CDP, people can access historical data anywhere where they can connect to the Google Cloud. And by default, we say Google Cloud. If you don't like Google, make a feature request on our repo. We'll add more backends. If you want to use S3, if you want to use torrents, maybe if you want to use IPFS, make a feature request, get some support, and we can get that done. So ingestion in JavaScript, really? Yep, absolutely. Before, we had a world in which we can only connect to the Stellar network, talk to smart contracts, blah, blah, blah. It's a very filtered kind of access layer that only lets you do what the backend lets you do. But now we have a world in which we can actually decode and parse metadata from CDP data lake, and that gives us the exact same power as the Go ingest package that some of you may have used or seen that powers some of the more like backend heavy applications. So we can do all that on the front end now. So what are the next steps at this beautiful point in time? We can turn this payment indexer into something a little fancier. You can render the payments pretty. You can add more different filtering options or show aggregate balances, add support for smart contracts, all this kind of stuff. The demo that I showed just does analysis of simple payments. You can make that analyze pretty much whatever you want. Or, there's some fun ideas about completely new things that you can do with this new architecture. Basically, you have the entirety of the data of the Stellar network at your disposal, and you can build all sorts of really cool things without relying on a heavy and complicated and resource-intensive backend to do all of the parsing and whatnot for you. So, fast, cheap, and easy. That's the theme of the day. Get to pick all three. The data's right there. Everything runs in your client, and it's JavaScript. How hard could it really be? That's pretty much it. Thank you, everybody, for your time. That was the demo. Browser-based love.
What George didn't add is it's so fast, cheap, and easy to use. He actually wrote this code on a train going across America. So
That is true, yes.
if you want a train project, try a browser-based backend. Okay, last but certainly not least, we're going to have Amisha, Urvi, and Aditya present. Hopefully, Amisha, we figure out all of your screen share microphone things.
Are you able to hear me?
Yes, we are.
Yes.
Excellent.
Okay, I'm gonna start presenting from here. Okay. That's good. All right. Hello, everyone. I am Amisha, and I would like to present on our hackathon project, which is real-time validator analytics using CDP. We scoped this project to understand biases in validators, if any exist. So, what are we really trying to demonstrate? Do you see my screen? Oh yeah, all right, yeah. So what are we really trying to figure out? So we want to answer these questions which we picked. Are validators nodes picked randomly as ledger leader? Are validator biased towards making transaction set with specific operations? Or do certain validators lead continuous ledger sequence more than others? Or how changes in Stellar core affect how validator makes transaction set? For example, limiting the number of DEX operations per ledger. So is there any suspicious activities going on? We want to figure that out. Can CDP answer above questions for the live data, or can it answer also for the historical data? Let's figure it out. So I'm gonna take you the dashboard which we built. Bear with me a second. Okay. So this is a dashboard which we created using Jupyter Notebook, and that was ingested with the static historical data created using CDP. So this first matrix demonstrates or calculates for how many continuous ledger a particular node led the ledger. So, or essentially, we want to know, are there any specific nodes which continuously close the ledger as compared to other nodes? So is there any what does the distribution looks like, right? So in this particular metric, as we can see, there are nodes, which has continuously closed the ledger for almost like 5 counts. So that's fine. But the thing is, it's uniformly distributed across different home domains. So you can see like, node from Lobster or Whale Stack or public node, they're equally closing the ledger for 5 continuous count. There could be more, right? Let's talk about another metric we studied. This one. So this represents how many ledgers are closed by node from a certain home domain per given day. So this is the data for September first week. And as you can see, almost everything looks fine, right? Like all the home domains have equal distribution in how they close ledger, with the exception of Lobster. So the Lobster, the green area is a little bit bigger than the other home domains. And the reason being, there are more nodes provided by Lobster as compared to other home domains. And this is right now a known issue which core team is actively working on. So this dashboard is created using static data from CDP. And I would like to present
Hey,
now.
Amisha, really quick. There's a lot of people. Some people can see your screen, but it sounds like about 50% of the audience can't. So do you mind unsharing and then re-sharing to see if we can get more people to see the screen?
Yeah. Sure. Okay. Does it work now? Hello. Yeah, it works now.
Yep, people can see now.
Okay, cool. Yeah, let's take a look at now the real-time analytics using CDP. So this is a Grafana dashboard, which is again fed by data from CDP, and it kind of tells you information in real time. For example, like what ledger sequence was closed just recently, what particular home domains close certain sequence number, for instance, like 561, it's closed by block daemon. And another important metric is our total operation count. So if you can take a look, like all the home domains have been very consistent across like how like how they close different sort of operations. For instance, this is public node closing operations, and this is block daemon closing operations. So that's very consistent across time. And let's take a look at another metrics, which is claimable balance operations. So I'm gonna give a little bit more time for the analysis. So let's say the claimable balances operations isn't very much aligning with the total operation count metrics. That's because claimable balances is a bigger chunk of our total operation count. So whenever claimable operations go up, which is always being reflective in our total operation count. So that's another interesting metric to study and also like kind of confirm our hypothesis. And the last metric I would like to show is the other operations one, which is so what are the different kind of operations performed by different node across different home domain. So as you can see, over time, say this particular node from Satoshi Pay is having, sorry, I didn't want to show this one, but operation breakdown by node. So this particular node by Stellar is performing or like closing transaction with claimable balances pretty consistently over time. So there are no spikes as such. And also it's very uniformly again distributed across different categories. So there is not like huge distribution between certain nodes preferring one operation over the other. So in conclusion, to recap, to answer our questions which we posed early, whether are there any suspicious activities going? From this analysis, we figured out that there are not really any suspicious activities going on. Like each of the home domain is working as expected. However, in case if there are, if this behavior change over time, we definitely have the ability to monitor it again using CDP, and then take actions and also like be aware as and when it happens, which was not possible until now. So with that, I'm going to back to presentation and talk about how we achieved it. So this is the architecture of our tool. So on the input end, we have a data lake of ledger metadata, and on the processing end, we have a processor which continuously ingests data from this input data lake, and then filters in the data, which is filters in the fields which are required for the analysis, and then puts it into 3 formats. So on the output end, we have static CSV files, which is used in Jupyter Notebook to compute those graphs. And then on the second, we have a JSON data stream where the processor continuously emits the data from CDP, and it could be used for real-time analytics. And then third is it also emits metrics events to Grafana, or actually to Prometheus, which is then wrapped by Grafana for the dashboard I just showed it to you. So now that I've talked about the technical architecture of our project, I wanted to touch upon why CDP and not Hubble. So the gist is fast, cheap, and easy. That's what that's the theme of today. So the first one is fast. So CDP provides us the ability to get data in real time. Which is why this analytics and monitoring is possible, unlike Hubble. So Hubble has a latency of around like 10 to 15 minutes, whereas CDP has latency within seconds to get your data then and there. And easy. So it's easy to build any lightweight analytics, with the data of interest, with a lot of customizations. So you don't need to bother about all the different data models. You just need to pick your own data model and then work on it. And then it's cheap. So there's no overhead of data warehouse setup as it is in Hubble. You just start a Go server and you're good to go from there. So overall, it's very easy, fast and cheap. Like for just context, like I wasn't very aware about CDP before this hackathon. However, in just 1 week, I was able to quickly, use CDP and apply this in project along with my team members. So what's next? So we would like to package and figure out the deployment option for this particular application. And then I'm sure these were just very few metrics we tracked. However, there could be more interesting metrics, which may give more insights in how validators behave or how certain changes in code affect the network. So we would like to collaborate with our core team to verify different hypotheses against data, and also like just be aware about any unexpected activity. So that is all about our project. It's really easy, fast, and cheap to use. And this is a source code for our project. If anyone is interested in taking a look or like give us some feedback or thoughts, and also some of the references which we use to carry out this project. Yeah, that's about it for our presentation. If there are any questions, we'd love to take.
Thanks, Amisha. We do have a little bit time left over, so if anyone in the audience has questions regarding any of the 5 demos they've seen, now would be the time to ask. I'm also going to post in, please join the Composable Data Platform Discord channel. I'm going to post a little roundup of all of these demos along with links to source code, screenshots, repos, that kind of stuff. So if you want to continue the conversation more, find us there. Otherwise, we have a little bit of time for questions right now. All right. Well, that's all we had. So see everybody in the Composable Data Platform. Come join us.